So this begins the Unit 5, Analytic Trigonometry. If you talk to students who've had this course in the past, they will tell you that this section tends to be the hardest section. And every once in a while I get a student who says they really enjoy this. And I'm not trying to make you not enjoy this, but the level of understanding in this section is much higher than any other section. So we're going to start out, we're going to evaluate some trigonometric functions, but we're going to be using the identities that are on page 350 in your textbook. So you really need to understand and memorize these identities. They're used in calculus without any review, so that's why you need to know them. So we're going to start out with just using some of the trigonometric identities by trying to find a trigonometric function. So I'll go through this with 4 examples, and then during the live lesson I'll do some other ones. So the first of all, I have to think, okay, sine theta is equal to 3/4. I'm given that information. Well, if sine is positive, then I know I'm looking for something in either quadrant 1 or 2. But then the other bit of information they give me is that cosine theta is greater than 0. So that means cosine is positive, and cosine is positive in quadrant 1 and quadrant 4. So I'm looking for an angle that's in quadrant 1, or I'm looking for a trig function that's in quadrant 1. So that's important information. So if I'm given sine theta is 3/4 and I want to find cosecant theta, then I'm going to use a reciprocal identity. So my reciprocal identity is that sine theta, let's do it this way, cosecant theta is equal to 1 over sine theta. So cosecant theta is going to be the reciprocal of 3/4. So it's equal to 4/3. So you've been doing this already. It's just now putting it into a more formal picture without drawing the diagram. You can draw the diagram if you want to, but you would get no credit for that. You have to actually tell me which identity you used and just find the one that's being asked for in this example. In the textbook, you're going to be asked to find all of them. So the second example, I have sine theta equals -7 over 9. So sine is negative in quadrant 3 and quadrant 4. This gives me cosine, and it's a positive number. Cosine is positive in quadrant 1 and quadrant 4. So I'm looking for something in quadrant 4. So I'm given sine and cosine, and I want to find the tangent. Well, the quotient identity tells me the tangent theta is equal to sine theta divided by cosine theta. So tangent theta is equal to -7/9 divided by 4 square root of 2 over 9. You've been doing these long enough now, fractions, 9s are going to cancel out. So I get -7 over 4 square root of 2. Rationalize the denominator. So I get tangent of theta is equal to -7 square roots of 2. Square root of 2 times the square root of 2, square root of 4. Square root of 4 is 2. 4 multiplied by 2 is 8. And that makes sense because in quadrant 4, tangent is going to be negative. My next example, I'm given cosecant theta equals 5. So if cosecant is a positive number, I'm talking quadrant 1 or quadrant 2. Tangent theta is greater than 0. So that means I'm talking quadrant 1 or quadrant 3. So I know that I've got to be in quadrant 2 or quadrant 1. So now I have to find a relationship between cosecant and cotangent. And looking back at my identities, well, okay, I know 1 plus cotangent squared theta is equal to cosecant squared theta. This is a Pythagorean identity. So I'm given cosecant, so I know 1 plus cotangent squared theta equals 5 squared. So 1 plus cotangent squared theta equals 25. Cotangent squared theta equals 24. Cotangent theta is equal to plus or minus the square root of 24. And that plus or minus is extremely important. I can reduce the radical. Now I have to go back and think, okay, I was quadrant 1 is where I wanted it. Cotangent's positive in quadrant 1, so I want the positive. So cotangent theta is equal to 2 over the square root of 6. And my last example on here is an identity that we don't use that often. So this is we're gonna use the cofunction identity. And it doesn't come up very often. The cofunction identity says that secant of pi over 2 minus theta is going to equal cosecant of theta. So this tells me cosecant of theta is going to be negative. So when I want to find the sine of theta, I also want it to be negative. So this is either going to be quadrant 3 or 4, which really doesn't matter which one we're looking at since we're going to get a negative. So my cosecant of theta is negative 5 over 3. Then I'm going to use my reciprocal identity. And I get sine of theta is equal to negative 3 over 5.